Welcome to another tutorial of the thermal system design course. So in this tutorial we're just going to finish the last three things that this problem asked us to, which is calculate the surface heat transfer coefficient, the average nozzle number, and the total heat transfer. So we already saw all of the other problems, which was the contours and the plots. In this case we're going to go to reports. We're going to click on it. And if you go to fluxes and you go to setup, you can actually go and select total heat transfer rate, and you can select it at the different places on your domain, or the different name selections that you selected. So we want the total heat transfer rate at the cylinder. So we click on compute. It's going to give us the answer right here, and also it's going to give us the answer on our console right here. So we can see that our answer is 5.61 watts. You can actually also save it. So if you click on write and you save it wherever you're saving all your files, and you open it with Notepad, this section, this calculation would be saved as well if you want to keep record on it. So let's close that. So now let's calculate the surface heat transfer coefficient. So we go to surface integrals, we go to setup, and we go to area weighted average. We select wall fluxes, and we go to surface heat transfer coefficient at the cylinder wall, and we compute it. We can see that we obtain our results as well right here. So our result is 2.13. So if we go here and we compare our result to our analytical solution, our result is 2.137, and in this case is 2.453. So in this case we use the nozzle number correlation from Churchill and Bernstein, and the Reynolds number is 100. Our PR is 0.7, our K is 0.024, and our diameter is 0.05 meters. We plot it into this equation, and that's how we obtain our nozzle number and our heat transfer coefficient. You can actually, if you see on this part of the equation, you already have K and you have D as well. And if you have your heat transfer coefficient, you can actually plot the one you obtain from your simulation from the ANSYS, and you can also calculate the nozzle number, so you can have a comparison between your theoretical and your experimental numbers. So after this, we finish this problem 1 of laminar flow over a heated cylinder.